Greetings, class. Theory of individual behavior. Video 2 of 3. Let's begin. So, in the prior video, this is a slide I stole from the prior video. We looked at how much to work now, how economists tackle that question. In this video, we're going to look at this one. How to divide income between spending and saving. And then in the third video of this series, we're going to look at number 3. These decisions that individuals make are all related, but we are examining them separately so that the mathematics doesn't get too hard. Let's go. So, this is a decision people have to make. Now, look, if you're really poor, you don't have to make this decision because you're forced to spend all your income, and in fact, you're often running out of income. This only becomes a decision when you have a decent amount of money. You're up there in the middle class or you're wealthy. So you can think about these 3 related decisions that I have here. How much to spend in total, what I'm talking about. How much to spend in total, how much to save, and how much to borrow. These are related. And the way economists think about it, as a person's going to have a certain amount of income in their whole lifetime, and they want to allocate it over the years of their life. Although we're not going to get into great detail, you could think about somebody borrowing a lot of money when they're younger to go to college, and then when they graduate, they start to pay that back. Then they might borrow money to buy a house. That's going to be a big one. And then they start to pay that back. And when you get older, in your 50s and 60s like me, now you got to start to save more and more in order to retire. At least that's the idea. So anyway, these decisions might vary by age and other things. And the whole idea is you have to compare. Remember, the whole idea of maximizing total utility. So each individual is trying to maximize their total utility. That's what they have in the back of their head. There's a certain marginal utility of spending now, and you can spend now either if you make money now or if you borrow money. But then you got to compare that to the marginal utility of spending money later. If you borrow money today and have to pay it back later, you can spend less later. If you save money, you give up spending money now and you can spend more later. So you have to think about all those things. And, you know, real human beings are probably not really great at this, but the point is that this theory assumes that people spend a lot of time on these decisions. So let's look at how interest rates affect this decision. Of course, many other things affect this decision. As I said, how much income you have, how old you are at this point in your life. Are you going to go to college? Do you want to buy a house? But we're going to just focus on one important thing, which is interest rates. So first, let's talk about borrowing money and interest rates. This one is kind of obvious. Higher interest rates make repaying a loan more expensive. You know, if it's a monthly payment kind of loan, then the monthly payment's going to be higher. So higher interest rates should reduce how much money an individual borrows. They just make it more expensive to afford something that you want to use today by borrowing money and paying it back over time. And of course, the same logic works the other way. When interest rates go down, it's less expensive to repay borrowed money. If it's a monthly loan like a mortgage, the monthly payment goes down, and that makes things more affordable. So lower interest rates should increase how much money an individual borrows. So there's no kind of surprise, I don't think, with how interest rates affect borrowing. But when we turn to saving, it's a little more complicated. Saving affects interest rates. You know, if you didn't think about this too much, at least I remember a long time ago when I was taking economics for the first time, I thought to myself as the teacher was lecturing, isn't it obvious that if interest rates go up, people are going to want to save more because the reward to savings goes up? But that's just me. There is this other thing that affects people. Just like when we talked about how the wage affects a person's desire to work, how there's two opposing effects. Well, believe it or not, those same two opposing effects occur in the way that interest rates affect saving. These are called the interest rate income effect and the interest rate substitution effect. Everybody is influenced by these effects. For some people, one is larger than the other, and for other people, the other one's larger than the other one. So it's just the magnitude that's different. These effects work against each other. It's like the person on the treadmill who has to eat bacon while they're on the treadmill. Both of those effects occur, and they work against each other. Now, the interest rate income effect relates to the amount of saving required to achieve a desired amount of future income. Suppose you're saving for retirement and your goal is to have $1 million when you retire at age 67. Well, if interest rates are high, you don't have to save as much because the interest you earn will take up the slack. On the other hand, if interest rates are low, you have to save more because you're not earning a lot of interest income. And remember, the power of compounding with interest is just phenomenal over many years. So in fact, when interest rates are high, some people, see this I didn't think about when I was first taking economics. When interest rates are high, some people might cut back their saving because they figure they'll earn so much in interest that'll make up the difference. The thing I was thinking of was this other one, the interest rate substitution effect. Well, if the interest rate goes up, every dollar that you save earns more, and that's an incentive to save more to get that extra earnings from the savings. So there's the interest rate substitution effect and the interest rate income effect. So let's look at how this works when interest rates go up and how it works with interest rates go down. So I have 2 pages on each one of those cases. Higher interest rates first and then lower interest rates second. So when the interest rate goes up, how does that affect how much money you want to save? Well, there's these 2 opposing effects. The interest rate substitution effect is when the interest rate is higher, the reward to each additional dollar of savings increases. This influences you to save more. So for example, if the interest rate on the savings account went from 1% to 3%, you put more money in the savings because you earn that extra 2% per year. But there's this opposite effect. Remember, everyone has these 2 effects. It's just a matter of how big they are. The interest rate income effect. If interest rates are higher, you can save fewer dollars and still have the same future amount of income as you did before the interest rate was increased. In other words, your interest income is higher, so you have to save less to achieve the same total desired level of income later. And this would cause you to save less. So these effects work opposite of each other. I have that as arrows on the next page. Here's the substitution effect of a higher interest rate, causing you to want to save more. Here's the income effect of higher interest rates, causing you to want to save less. So how it affects each individual depends upon how big each effect is relative to the other one. And this can vary by individuals. I like to think of myself as someone who values savings. I got a big for me, savings college fund for my kids. Of course, college is so expensive, it only would pay for, right now, maybe a year and a half. But for me, it's a lot of money. And I don't have any credit card debt, and our mortgage is paid off, and my car is paid off. So you see, for me, a bigger saver, this effect is probably bigger. For a person whose substitution effect is larger than her income effect, a higher interest rate will cause her to save more. That's someone like me who values savings. Now, my wife, who actually earns more money than me, I probably shouldn't tell you this, but she she seems to not have much of a inclination to save money. And so the kids' college fund is all me and contributing, and her car's not paid off. She drives a really nice car, but she has a big monthly payment and things like that. So for her, maybe the interest rate income effect is bigger. A person whose substitution effect is smaller than income effect, the higher interest rate will cause her to save less. So this is important. If you're, for example, if you're a bank and you think raising the interest rate on your savings will cause people to save more, well, the only reason it might really work is if people change banks. It's not like your customers will necessarily each put more in their savings account. If you can attract more customers from other banks, your total savings might go up. But you have to be careful. Now let's look at the opposite effect. How is savings affected when interest rates go down? It's the exact same logic, but now it's working the other way. If interest rates go down, the reward to each additional dollar of savings is smaller. So if you're only saving 1% and it used to be 5%, you're like, well, should I bother if I only earn 1%? I used to be earning 5%. So that would cause you to save less. But the interest rate income effect works the other way. Suppose you have a goal, you want to have $1 million by the time you're retired, and the interest rates on your accounts goes down. Well, now you're like, darn it, I got to save more. I got to have that $1 million when I retire. My interest income has gone down. I have to save more now in order to achieve my desired future amount of income. So again, these two effects, they always exist and they always work in opposite directions. In the case of an interest rate decreasing, let's go to the next page. I have the same ideas here, but with the arrows. The substitution effect encourages people to save less when the interest rate goes down. The income effect encourages people to save more when the interest rate goes down. So each of these effects works against each other. Each person has a different magnitude of the effects. So for a person whose substitution effect is larger, a lower interest rate will cause her to save less. But for a person whose substitution effect is smaller, a lower interest rate will cause her to save more. So this is the summary. For an increase in interest rates, substitution effect encourages the person to save more, income effect encourages the person to save less. And then for a reduction in interest rates, it's the opposite. Substitution effect encourages the person to save less, income effect encourages a person to save more. So try to understand this logically, and because when you try to memorize these things, at least for me, I tend to lose track of these things. Now, there are other things that affect the decision on spending, borrowing, and saving. I just want to mention two of them because these are things that affect businesses. Consumer confidence. When consumers are confident, savings tends to go down. By the way, this is true as I record this video in January 2018. The percentage of income that people are saving in the U.S. is at its lowest it's been in almost 20 years. People are so confident about, for example, their job security. If you're confident about your job security, you don't have to set aside money in case you lose your job. And so well, my job is secure, let me go out and buy that car I've always wanted. And the savings goes down and the borrowing goes up. The other thing that can affect saving and borrowing is how much inflation people are expecting. Future prices, right? Inflation. Let me put that in here. If you expect a lot of inflation, you might want to borrow now and spend now when things are relatively cheap. Think about a house. If you think housing prices are going to skyrocket in future years, you're going to do everything you can if you want a house to buy one today so that you lock in that low price. And then you own the house, and when the prices go up, your value of your asset, your house, goes up. So expectations of high inflation tend to make people borrow and spend now. But if people expect deflation, which means prices going down, they delay they delay. So if you think housing prices are going down, for example, you might say, well, let's wait to buy a house a couple years from now. It'll be cheaper. And so what do? You put money aside so that you can have a big down payment. And so you save more and borrow less when you expect prices to go down. Now, what else can we do with this question about how much to save versus spend? Well, there's a thing called an intertemporal budget constraint. See, saving money now can move your spending into the future. So, like my son's college account, I'm saving money now so that when he turns 18 and gets into Harvard or MIT or something, I will be able to spend more money later by saving it now. So it's like a time machine. Intertemporal means between time periods, really, right? So we're going to look at how spending and saving occurred between time periods. So how are we going to do this? Well, I don't want it to get too tricky. So first of all, we're not going to look at a person who lives, say, for 80 years or 90 years. We're going to look at this fictitious hypothetical person who only lives for 2 years. And the second thing I'm going to do is pretend that it's impossible to borrow money. And that means you can't borrow money today and repay it later. That makes the budget constraint more complicated. So all you can do is save money now and spend it later. You can't borrow money now and pay it back later. So let's build an intertemporal budget constraint under these conditions. A person lives 2 years. They can borrow money. They cannot borrow money. Sorry, they can't borrow money at all. They can save money now if they want to spend more later. So here's the example that we're going to. Now, a budget constraint is an equation. So we're going to have an equation here. You could draw it. I'm not going to, but you could draw it too. But we're just going to have the equation. So here's Biff. He only lives 2 years, like I said. During the first year, he earns $9,000. During the second year, he's retired, so he doesn't earn any money. That means if he wants to spend money in the second year, he's got to put money aside in the first year. So during year 1, he can choose to save some of his earnings and earn interest of 5%. And then the idea is, in the second year, he can spend all that savings and the interest that he earned. So the idea is he's allocating his earnings over time so that he can spend some money in year 1 and also in year 2, even though he has no earnings in year 2. Now, what's this equation going to look like? Well, before we do the equation, think about the different options available to Biff. And he's, remember, trying to maximize his total utility. He gets utility from buying things today, this year, but he also gets utility from buying things in the second year. But the only way he can buy things in the second year is by saving money today, which means he has to give up some buying this year. So here's 3 examples. He could spend the whole $9,000 in the first year and have no money to spend in year 2. Now that's probably not optimal because he would die in year 2. He wouldn't have any money for food or anything like that. What else could he try to do? He could try to spend nothing in the first year, assuming he doesn't die. In the next year, he would have all the money and 5% interest to spend. The trouble with that is it's probably not optimal. Again, in the first year, he would be able to buy nothing, and we'd get no happiness out of that. Now, if you kind of split the difference, he could save half of his money in the first year. That would mean he could have $4,725 to spend in the second year. That's the $4,500 of savings plus the 5% interest that he would earn on that. Now, there's all kinds of other options for Biff. We can't list them all, but we can make an equation that represents them all. This equation is called an intertemporal budget constraint. So here it is. We have a C with the subscript 2. C stands for consumption. Economists tend to use a C for spending. You can imagine using an S for spending. By the way, if you use an S on the test, as long as you tell me what the letters are, you can use any letter you want. The trouble with S for economists is that S means supply, you see? So if you use an S, people get confused. So C stands for consumption. The subscript 2 means spending in year 2. The C1 is consumption in year 1, or spending in year 1. And these are related like this. The thing in parentheses here, now 9,000 is how much he earned. If you subtract how much he spent, that's the amount he saves. So the thing in parentheses is Biff's savings. And so he gets to spend that in the second year when he withdraws it. But he also gets interest that he can spend in the second year. And by the way, there's no taxes in this fake world. So how much can he spend in year 2? Well, he can spend how much he saves, which is this thing in the parentheses, plus the interest that he earns on that savings. So we can use this equation to figure out how spending in year 1 relates to spending in year 2. And the idea is exactly what you would think. The more he spends in year 1, the less he can spend in year 2, because his savings is going to be lower. So let's do a couple of examples that use this intertemporal budget constraint. Now, I've just rewritten the intertemporal budget constraint here at the top, so we don't have to refer back. Biff spends $7,000 in year 1. How much will he spend in year 2? Well, let me copy and paste this down here, and we'll use it. Now, what do we have to do? We have to plug in this number, but where does it go? Well, this is the spending in year 1. That's what it says. So this is C1. So we put it in here, right? Put it in here. Well, I guess I shouldn't have abbreviated that. I mean, deleted that. Here, let me do it. Let me do it right below that. I'll paste it again. And so we put the 7,000 in here. Now it's just a math problem. Hopefully we'll be able to do it. 9,000 minus 7,000 is 2,000. That's his savings. He saved $2,000. He spent 7,000. He earned 9,000. That leaves him 2,000 to save. He'll earn interest on that of 5%. 1 plus 0.05 is just 1.05. And so 2,000 times 1.05 is $2,100. And that's the answer. He'll spend $2,100 in year 2. By the way, you know, if I ask a question like this on the test, you don't have to use this equation to get the right answer. I'd like to see calculations. I don't want you to just take a guess. But you don't need this equation to get this answer. If you don't want to use it, that's fine. But what I want to show you is that equations can be very useful. When you try to automate calculations, put them into a computer program or a macro that you've written for Excel or something like that, you have to use an equation. The computer will use the equation. When you're just doing a calculation for a test, I'm not going to ask you to use the equation. I just want you to get the right answer. But I would like you to know, for purposes of the real world, that equations are useful. Now there's many different ways you can use a intertemporal budget constraint. I got one more example, but it's not like these are the only things you can do. So let's do it again. I'm going to copy this again. I put it here just so we can see it. I'm going to put it again down here. Okay. Biff wants to spend $4,000 in year 2. How much must he save in year 1? Again, this is not something you need this equation to do, but I'm going to use the equation anyway. So how do we do this? Well, we have to plug this 4,000 in. Where does it go this time? He wants to spend 4,000 in year 2. This is his goal. Year 2 is C2. So we put it in the equation in place of C2. So I'm going to paste it and put it in. Now we got to solve this. Now this is a little bit harder of a math problem. Right? There's different ways to solve this problem. What can we do? Let's see. How about if we here, let's see. I'm trying to think of the easiest way to do this. Suppose we take the 1 plus 0.05 and make it 1.05, okay? Now what we can do now is divide both sides by 1.05. So you'd have, what would you have? If you divide both sides by 1.05, let me copy and paste and then I'll do that. You'd have 4,000 divided by 1.05 equals 9,000 minus C1. Now if we do 4,000 divided by 1.05, I haven't done it yet, let's see. I'm going to open Excel and do it. You can't see this because it's on my other monitor, but I'm opening Excel to do this calculation. Well, let's see, here I go. 4,000 divided by 1.05. We got 3809. 3809.524 equals 9,000. There, let me take the dollar sign off. They are dollars. 9,000 minus C1. So if we now subtract 9,000 from 3809.524 from 9,000, we will get what C1 is. It wants to make it a subscript. Hold on a second. Where's the subscript thing? Get rid of the subscript. So we got to do 9,000 minus 3809.524. C1 equals, doing that math, let me turn this into a subscript. 9,000, let's see, I'll do it over here in Excel, you can't see. $5190.476. Now, is this the answer? What's the question? The question is, how much must he save in year 1? Right? If I can just... How much must he save in year 1? Is this savings in year 1? This is spending in year 1. So that's not the answer. How does this help us? Well, if we know how much he spent in year one, we know he earned $9,000 in year one. So, savings in year one equals 9,000 minus, right? If you earn 9,000 and you spend 5190.476, whatever's left over just will fit in my screen is the savings. So you have to save 3,000, $3,809. The software does some strange things. I can't put a space in here. I don't know why I can't put a space in there. Well, there's a bit of bigger space. It just keeps wanting doing the calculation. So this is the answer, right? This is the answer. You got to save $3,809.52.4 to have $4,000 to spend in year two. Now there is an easier way to do this. 4,000 divided by 1.05. That's what that number is. You don't need to use the equation. Of course, some software, you put the equation in and that's how it would get the answer. But this is the idea. The intertemporal budget constraint is a way to quantify all of the options for BIF in relation to spending and saving over the various years. So we've done number 2 here. The next video we're going to tackle number 3. Until then, Dr. Williams is saying, have a good day.